A 23-year-old banker walks into a gym, lifts weights, drives himself to work. Nothing remarkable, except that just a few years earlier, doctors told him he would never move anything below his neck again. A catastrophic car crash in 2018 had shattered his spine. The diagnosis, tetraplegia. So what changed? Not a miracle, not some experimental treatment flown in from abroad. The answer came from a university lab in Rio de Janeiro, and it could reshape everything we know about spinal cord injuries. Every year, roughly 500,000 people worldwide suffer a spinal cord injury, and for most of them the story ends there. Here's why. Your spinal cord works like the main data cable connecting your brain to the rest of your body. Every command to move a finger, every sensation from your skin, it all flows through this single channel. When that cable gets severed, the brain keeps sending signals, but nothing gets through. That's paralysis. What makes it worse is the body's own response. After the initial trauma, inflammation kicks in. The body tries to contain the damage by forming dense scar tissue around the injury. Think of it as the body sealing off a broken tunnel, except now, nothing can ever pass through again. Those severed nerve fibers, called axons, have no way to reconnect. That's the cruel irony. The body's defense mechanism becomes the biggest obstacle to recovery. For patients with complete spinal injuries, the chances of regaining meaningful motor function hover around just 10%. For decades, the medical consensus has been clear: once the cord is damaged, the best you can hope for is adaptation, not recovery. That was the world Bruno Drummond just woke up to in a hospital bed at 23 years old, facing a future that seemed permanently rewritten. But halfway across the city, someone had been working on a solution for nearly 3 decades. This story doesn't start with a breakthrough. It starts with patience. Dr. Tatiana Sampaio, a biologist at the Federal University of Rio de Janeiro, spent her career studying a protein called laminin. During embryonic development, laminin acts as a kind of molecular GPS for neurons. It builds the pathways that guide nerve cells to connect with each other. Without it, our nervous system simply wouldn't form. The problem: in adults, laminin levels drop dramatically. The body no longer has the raw material to rebuild damaged neural pathways. But Dr. Sampaio found something remarkable. Under specific laboratory conditions, individual laminin molecules could be coaxed into linking together, polymerizing into a larger, more stable structure. She named this new form Polylaminina. And then came the bold hypothesis: what if this engineered protein could serve as a biological scaffold? If you could inject it directly into a damaged spinal cord, could it provide a physical framework, essentially a temporary bridge, that severed axons could use to grow across the injury site and reconnect? Her team tested it on rats with spinal cord injuries. The results were striking. Animals treated with polylamina showed significant improvements in movement. Under the microscope, the evidence was clear. Axons were actually growing through the damaged area. On top of that, the protein demonstrated powerful anti-inflammatory properties, reducing the very scar tissue that normally blocks any chance of healing. But getting from a rat lab to human patients is a massive leap, especially in Brazil, where scientific research chronically struggles for funding. At one point, the financial situation became so dire that the university couldn't even maintain the international patent on the technology. Still, the team pushed forward, backed by UFRJ, the Rio de Janeiro State Research Foundation, and a critical partnership with Cristalia, a Brazilian pharmaceutical company. The work continued. Cristalia invested in scaling up production, ensuring the protein could be manufactured with the purity and consistency required for human trials. After more than 20 years of painstaking work, the scaffold was ready. Now they needed patients brave enough to test it. Bruno Drummond detritus's accident in 2018 shattered vertebrae C6 and T8. He was diagnosed with tetraplegia, complete loss of movement and sensation below the neck. But the medical team treating him was aware of Dr. Sampaio's research at UFRJ. They presented the option to Bruno's family in what can only be described as an extraordinary leap of faith. The family agreed. Less than 24 hours after the accident, during the emergency surgery to stabilize his spine, Bruno became one of the first humans to receive a direct injection of polylamina into his injured spinal cord. Nobody knew what would happen next. The protein isn't a switch you flip. It creates conditions for regrowth, but the actual recovery demands grueling, intensive physical therapy, retraining the brain and muscles to talk to each other through newly formed connections. Weeks went by, and then less than a month after surgery, Bruno moved his big toe. It sounds small. It was anything but. That tiny flicker of movement was proof that somewhere inside his spine, nerve connections were being rebuilt. From that moment, his progress accelerated steadily. Bruno's case was remarkable, but not isolated. A pilot study conducted between 2016 and 2021 included 8 patients with acute spinal cord injuries. 2 patients died from complications related to the severity of their injuries, deaths unconnected to the treatment itself. Of the remaining 6, every single one showed some degree of motor or sensory recovery. Compare that to the 10% spontaneous recovery rate in the medical literature, and the significance becomes hard to ignore. The results opened the door to the next critical phase. Asterisk promising lab results and a handful of successful cases aren't enough to call something a cure. For polylamina to become an actual treatment available to patients, it needs to survive the rigorous clinical trial process overseen by Anvisa, Brazil's national health regulatory agency. In early 2026, Anvisa gave the green light. The agency authorized the Phase 1 clinical trial, marking polylamina's official transition from research project to drug candidate. Phase 1 isn't about proving the treatment works, it's about proving it's safe. The study, sponsored by Cristalia, will enroll 5 new volunteer patients. The criteria are strict. The injury must be acute, located in the thoracic region of the spine, and the treatment must be administered within a critical 72-hour window after the trauma. These patients will be monitored closely for at least 6 months. If Phase 1 succeeds, the research can advance to Phases 2 and 3, larger studies designed to measure actual effectiveness. If everything goes well, experts estimate polylamina could be available as an approved medication within roughly 5 years, and there are already discussions about making it accessible through Brazil's public health system. But it's important to stay grounded. The Brazilian Academy of Sciences and SBPC have both urged caution against disproportionate expectations. Polylamina is not for sale. It is not a proven cure. Its use remains confined to research protocols. Major questions remain unanswered. How effective will it be in a larger population? Will it work for chronic injuries, cases where years have passed since the original trauma? So far, the research has focused exclusively on acute injuries. Still, the progress is real. Bruno Drummond now describes his life as 100% independent. His story has put Brazilian science at the forefront of a global conversation about spinal cord regeneration. Asterisk, what happened here goes beyond a single protein. This is a story about what becomes possible when a country invests in its researchers and its institutions. Dr. Tatiana Sampaio and her team at UFRJ spent almost 30 years turning a laboratory observation into something that gave people their lives back. But this journey also exposed uncomfortable truths. Brazil nearly lost this technology entirely, not because the science failed, but because the funding did. A discovery with the potential to change millions of lives almost disappeared due to budget cuts. That should be a wake-up call. Science is not an expense. It's the highest return investment a nation can make. The road ahead is long. Phase 1 is just the beginning, and we need to let the process run its course. But something has fundamentally shifted. The idea that spinal cord damage is permanent, that irreversible is the final word, is being challenged by evidence, by data, and by the story of a young man who was told he'd never walk again. He walks now, and behind him, a bridge built by Brazilian science is pointing toward a future that, not long ago, no one dared to imagine.